Hi students, welcome to the next session. So in the previous session we have discussed the basics of the chemistry. So in this session we are continuing that the law of chemical combinations. So there are total 6 laws of chemical combinations. So one is law of conservation of mass. See, whenever there are there is a reaction that happens. For example, during a reaction some A is mixed with B. Okay, some element A is mixed with element B. So A plus B gives rise to another new element, that is AB. Okay, it gives a new compound called AB. Now the mass of A, like it is Ma, the mass of B is Mb. So the mass of A plus mass of B will be equal to the mass of the new compound that is formed, that is mass of AB. This is called law of conservation of mass. Okay, the total mass of the reactants will be equal to total mass of the products. So like this, for example, H2O, 2H2, 2H2 means H hydrogen's mass is how much? Hydrogen's mass is like it is 1 gram. So 2 hydrogens, total 2 into 2, 4 hydrogens we have taken here. So total hydrogen's mass before reaction is 4 grams plus oxygen's mass is, oxygen atomic number is 8, atomic mass is 16. So 16 2s are 32. So 2 oxygens are participating here. So 16 2s are 32. So 32. So total mass before reaction is 36. If you look at H2O, so H2O again there are 4 hydrogens here and 2 oxygens. Okay, again the total mass, H2O's mass is how much? H2 is 2, O is 16, 16 plus 2 18, 18 into 2 36. So H2O's mass is how much? So H2O mass is 18. There are how many H2O's are there? 2 H2O's are there. So 18 into 2 36. If you look at this, so the mass of the reactants is equal to mass of the products. This is called law of conservation of the mass. So law of constant composition or definite proportion. See, as I told you in the previous session, so whenever we take any water, it may be water from a sea, water from a glass of water, water from a glacier. So everywhere you take water, the composition of water will be, there will be hydrogen, 11.2% will be hydrogen, and 88.88% will be oxygen. That means here if you look at this, so in H2O there are 2 grams is what? So 4 grams is what? H2O, in H2O 2 grams is hydrogen, 16 grams is oxygen. So 2 by 16 means how much? So 1 by 8. So 1 by 8 into 100 if you do, you will get 11.2. So in the similar manner, so 11.2 remaining portion, 100 minus 11.2 is 88.8. So the hydrogen part is 11.2, the oxygen part is 88.8. So wherever you take water, all the water will have the same proportion. Okay, it is called definite proportion or constant composition. Composition means what? The constituent arrangements means if there is some A, B, both are arranged in such a way, wherever you take the A, B value, the ratio will be same. So you take from this part, you take from that part. So for example, this is a compound. So here if you take A, B, so the ratio will be same. Here if you take the same water droplet, the ratio of hydrogen oxygen in any water droplet, it will be same. So law of multiple proportions. Here if two elements form more than one compound, for example you take carbon dioxide and carbon monoxide, so C plus O, let it be CO. Okay, C plus O2 or 2C plus O2 gives rise to 2CO, or C plus O2 gives rise to CO2. Now here so first of all, here we have taken 2 carbons. 2 carbons means how much? It is equal to 6 carbons, atomic number is 6, atomic mass is 12, 12 is 24. So 24 is the mass of the carbon we have taken. Here we have taken 2 oxygens, means 8 to 16, 16 to 32. So 24 grams is reacting with 32 grams of oxygen. Here 12 grams, 1 carbon is reacting with O2. So that means 8 to the 16, 16 to the 32. So here 12 grams is reacting with 32, 24 grams is reacting with 32 grams. Means if I take 12 grams here, then it needs at least 16 grams of oxygen. So if 24 grams of carbon is needing 32 gram, so needs 32 gram. So now 12 grams of carbon needs 16 grams of oxygen, right, in carbon monoxide, for forming carbon monoxide. So now if you take the ratio of 16 and 32, the oxygen requirement here, so C plus O, so wherever we have carbon monoxide, the oxygen requirement per carbon, 12 grams of carbon is 16 gram. Whereas in carbon dioxide, the oxygen requirement per carbon is 32 gram. So if you take the ratio of these two, so 16 is to 32. So here the oxygen requirement from carbon monoxide, the oxygen requirement from carbon dioxide, if you take 16 is to 32, that is 1 is to 2. So it is a simple ratio. Likewise, you can also do it for NH3 and NH4. These are the two compounds. So NH3, N is nitrogen, nitrogen's atomic mass is atomic number is 7, so atomic mass is 14. See, it is 14. Now hydrogen's atomic mass is 1. Okay, now it is 3 hydrogens are there. So the total in NH3, nitrogen's atomic mass is 14, hydrogen's atomic mass is 3. In N2H4, so there are 2 nitrogens means 28, 4 hydrogen means 4. So for see here, for for 14 it is 3, right? Here for 14 that will be 2. So 28 by 2, 4 by 2. So 28 grams need 4 grams, or 28 units of nitrogen needs 4 units of hydrogen. In the same manner, 14 units needs 2 units of nitrogen. So now here 14 needs 2, here 14 needs 3. 14 needs 3. The ratio is 3 is to 2. For NH3 and NH4, the requirement of hydrogen is 3 is to 2. It is also a simple whole number. This is the law given by Dalton in 1803. That is called law of multiple proportions. We can also use this law for hydrocarbons, CH4, C2H6, like this. If you compare here also, you can apply this law of multiple proportions in organic compounds like carbon compounds. Okay. Now next law is law of equivalent reciprocal proportions. When two elements combine separately with the same fixed third element, then the ratio of the will be same or the multiple of a ratio another compound. See here CH4. So see, one carbon is reacting with 4 hydrogens. See, one carbon is reacting with how many hydrogens? 4 hydrogens. Same one carbon is reacting with 2 oxygens in CO2. So one carbon is reacting with 2 oxygens. Now when these two react, so their ratio will be in this. So when 2 hydrogens, so if you divide this, 2 ones are 2 twos are. So one oxygen needs 2 hydrogens. One oxygen needs how many? 2 hydrogens. So now the compound will be like this. The compound will be H2O. The compound will be H2O. So this is the law of equivalent or reciprocal proportions. Means when two elements combinedly, okay, when two elements combine separately with a fixed mass of third element, means here this is the third element. A hydrogen and oxygen are two elements which combine with a fixed mass. So these 4 hydrogens are reacting with 1 carbon only. These 2 oxygens are reacting with 1 carbon only. So fixed third element. This is the fixed third element. Their ratio will be same. Okay, their ratio will be same or a multiple. Here, or either they may react like H4O2, but this compound will not exist, or take a multiple of their ratio. So that means 2 into H2O, a multiple of their ratio in another compound. In case if these two reacts, they form a compound like this. That is a law of equivalent or reciprocal proportions given by Richard in 1794. Law of combining volumes. So gases react in a simple whole number. For example, some gas. Okay, so N2 is a gas, nitrogen, has reacted with hydrogen gas. Now gases react in simple whole numbers, means one volume of N2 reacts with 3 volume of hydrogen at constant temperature. Okay, so the reaction, so here the ratio of these volumes will be in a whole numbers. So 1 is to 3, 1 is to 2. So it cannot react with a volume of half volume or 2 by 4 volume like that. It reacts only in a volumes of a whole numbers. So 1 volume reacts with 3 volume like that. Okay, so it depends on how many moles. So 1 mole is taken as 22.4 liter at standard temperature and pressure. We will discuss detail about these law of combining volumes and all in the coming topics, in the coming lessons. Okay, you will these are the basics which we are discussing here. We will go in detail about these laws whenever we discuss about any kind of reactions and balancing them. Okay, now so Avogadro's law: equal volumes of all gases occupies equal volume of all gases at the same temperature. Yeah, so contains equal number of molecules. See, or else equal 1 mole of any gas occupies same volume at standard temperature and pressure. Okay, for example, 1 liter of O2 and 1 liter of N2. In these two elements, so the number of molecules will be same. The number of molecules will be same. Or we can also say this Avogadro's law like this: 1 mole of any gas, 1 mole of any gas, 1 mole of any gas occupies, any gas occupies how much at STP? At STP is equal to 22.4 liter. So this is the value of volume. So any gas, irrespective of any gas, it occupies 22.4 liter of volume at a standard temperatures and pressure. Okay. So above these laws, if you understand these laws very well, so you can use these laws for for finding any kind of new compounds using in chemical reactions. So we can find new molecular formulas. So we can understand how gases behave in different conditions, and all these things we will learn in the upcoming classes. Okay. So let us go to the Dalton atomic theory. So actually Dalton is the scientist who termed that atom is indivisible. Atom is a basic unit of any kind of matter. So accordingly, he has given some postulates in his theory. So let us see one by one. These postulates and all are not new for us. We are learning these postulates right from our 8th class or 9th class also. So atoms are indivisible. So atoms are the smallest indivisible particle of any matter. Atom, we cannot destruct it. Atom participate in chemical reaction as a whole. So this atom cannot participate a half atom or 1/4 atom, a quarter atom. It will not participate. The atom itself as a whole, it participate in a reaction, in a chemical reaction. Okay. So and whole numbers of ratios, as I told you already, half atoms does not exist. Okay. Whenever in any compound you find only a complete atom. We cannot find half atom or a quarter atom. Identical atoms form if in an element. If you take an element, hydrogen, oxygen, nitrogen, so all the atoms are identical. We don't find one atom bigger, one atom smaller, or one atom has one more electron. Like that, it does not happen. So all the atoms for a particular element will be identical. They have the same mass and same type of chemical properties. Reorganization in chemical reaction. See, generally all the available compounds in our nature are made up of rearrangement of these atoms only. So one atom will break reaction with another atom, and it forms new reaction with some other compound, or an atom forms new kinds of compounds. Okay, and it got new chemical properties. So like this, the atoms reshuffling or rearrangement of these atoms causes various kinds of compounds which we see in our real life. Okay, limitations here: atom is not divisible, but some subatomic particles are existing like electrons, protons, and neutrons, which were not discussed by Dalton during the explanation of this atomic theory. Okay, so isotopes and isobars. Whenever we take about atom is not destructible, or atom may be same, but it may have some different kinds of characteristics by one same element may have different isotopes. Okay, so two elements may have same isobars. So like this. So these were not discussed in Dalton's atomic theory. Okay, so this is the basis for different kinds of atomic models. So atomic theory, first atomic theory laid the foundation for futures for the next coming atomic theories and all. Okay, so let us see what is the next session. Now, atomic and molecular formula mass. So for an atom there will be atomic mass. For a molecule, a group of atoms, we consider it as a molecule. So for a molecule there will be molecular mass, and for the same molecule we also calculate formula mass. So we will see what is the difference between molecular mass and a formula mass. Let us see. So atomic mass means what? So earlier we used to take hydrogen as a criteria for finding the atomic mass, but later after finding tritium, deuterium, which hydrogen's isotopes, so we changed it to carbon for having a better accurate measurement of mass, because carbon is evidently available. Majority of the compounds are made up of carbon, so that is the reason why carbon is fixed as the basic element. So that too, carbon is also having different types of isotopes. So we have taken carbon 12 isotope. Means isotopes we will discuss later. Isotope, briefly I'll tell. Isotope means an element which is same element having different atomic masses. So all those elements are considered as isotopes, because for example, if you take carbon, so carbon atomic number is 6. The carbon may have an atomic mass of 12, same carbon may have atomic mass of 13, same carbon may have atomic mass of 14. So these element carbon is having same atomic number but different atomic masses. So all these three are considered as isotopes. These are considered as isotopes. Okay. So generally carbon 12 isotope we take. This isotope we take in that carbon 12 isotope means atomic mass is approximately equal to 12. So 1/12 means what? So 1/12 of 12 means what? It is approximately equal to 1. So that means we are taking 1 as a unit. So 1 by 12, we are dividing 1/12 of the mass of the carbon, means we are taking the denominator as 1 only. So that means the atomic mass of hydrogen with respect to this carbon isotope is coming as 1.008. Okay. Now, the gram atomic mass is the same atomic mass. If you represent in terms of grams, that is called gram atomic mass. So, the atomic mass, nothing will change. The numbers will not change. The unit only changes. Okay. From atomic mass unit, we take it as gram. So, gram atomic mass means the only thing here, the unit of mass is taken as a gram. So, Dulong and Petty's law of metals. So, for metals only, it will be helpful. We can apply this metal, Dulong Petty's law. That means approximate atomic mass. Before the periodic, before the discovery of periodic table and all, before that we are discussing all these things. At that time, for having a rough atomic mass calculation for metals, so they have created this empirical formula, so where the approximate atomic mass which is related to specific heat of that metal, so 6.4 upon specific heat, so valid for most solid metals except so beryllium. For beryllium, carbon and silicon, this thing will not acceptable, this thing will not fit, except that almost all the solid metals, this theory holds good for getting the atomic mass. So approximate atomic mass as per the Dulong-Petty's law of metals is 6.4 upon specific heat of the solid. What is specific heat and all we will discuss in thermodynamics lesson. Just wait for a while. Okay. If I explain everything here, that then this session will be bulky and it will deviate from the core concepts which we need to discuss in this lesson. Okay. So that is the reason why I don't discuss much about these concepts here. We will discuss these concepts in thermodynamics lesson. Okay. Exact atomic mass. Exact atomic mass is the equivalent mass into valency. See, again, what is not equivalent mass? In the next slide only I will explain this. Okay, so if you know the equivalent mass, if you know the valency I think 9th standard we have seen. So the valency means in any element, so octet configuration for any element tries to gain the octet, right? So for gaining the octet means what? 8 electrons in the outermost shell, 8 electrons in the outermost shell, that is called octet. Okay, now for getting this octet, sometimes the atom have to lose the electrons, sometimes the atom needs to take some electrons. So how many electrons it has to lose for achieving this octet, or how many electrons it has to gain for achieving this octet is considered as the valency of that particular atom. Okay, so into equivalent mass will give you exact atomic mass. So most elements have isotopes, so their actual atomic masses is a weighted average. See, sometimes, as I told you right now, isotopes. So same element may exist in nature in with different atomic masses. So in that case, we cannot take single mass directly. So what is the existence? What is the weighted average means what? So 6C12, for example, this element is it has existence of 60% in the universe. For example, I am telling this is an example. For example, carbon 12 isotopes is having 60% existence on Earth. Carbon 13 isotope, it is having a 30% existence on this Earth, and remaining 10% existence is for carbon 14. Now, according to this existence, see, for example, M1, M2, M3 are the atomic masses. So 12, 13, 14 are the atomic masses. M1 is 12, M2 is 13, M3 is 14, for example. Now, R1, R2, R3 are the relative abundances. So that means 60%. This is for 60. This existence is 60%. We take it as 0.6. This existence is 30%. We take it as 0.3. 30 by 100. Relative existence means what? So 60% is existence. Relative abundance means 60 by 100. Relative. In 100 we are finding 60. That is relative. So likewise 14 into 0.1. So if you do this, you will get the total mass, total average mass. This is average atomic mass. This is average atomic mass considering relative abundance of the element. For example, carbon, if you take carbon 35, so chlorine. So chlorine 35 is having abundance of 75%. It is having abundance of how much? 75%. And 37 is having abundance of 25%. Now what I will do is, if I want to measure the average atomic mass of the chlorine, then I need to do 75 by 100 into mass of this first one, 35 plus 25 by 100 into 37. This means M1 R1 plus M2 R2 by R1 plus R2 means what? This one R1. This one R1, this one R2. R1 plus R2 is how much? 100. So R1 plus R2. What I am doing? R1 plus R2. So likewise, we can find the average atomic mass when you are finding isotopes. Okay, by taking the relative abundance into consideration, or simply we can call it as weighted average. Okay. Now, molecular mass means sum of the atomic masses of all the atoms in the molecule. Simple. So we have H2O. Hydrogen's atomic mass is 1. So 2 hydrogens are there. Then it is 2 atomic mass unit, and oxygen it is 16. So 16 plus 2, 18.01 is approximately. Formula mass. See, for example, formula mass means used for ionic compounds where discrete molecules do not exist. See, generally single molecules, if it is not existing, discrete molecule means what? Isolatedly the molecule, if it is not existing, then we calculate by adding atomic masses of all atoms in a formula unit. So in one formula unit, how many atomic atoms are there in a formula? Formula mass. Okay, here with respect to the formula, we are measuring the mass, formula mass. Here sodium having a formula as per sodium, it is 23, chlorine 35.45. Simply adding these two, you will get the formula mass. Or also another thing is there, formula mass. About this formula mass we will discuss. Another formula is also there which we don't discuss here, later we will discuss. Okay, next is equivalent weight, very important. It is the weight of an element or a compound that combines with or displaces 1 part of hydrogen or 8 parts of oxygen or 35.5 parts of chlorine. See here if you look at this, what is the valence of hydrogen? Valence of hydrogen is how much? 1 because hydrogen number of electrons is 1 electron it will have, and nearest noble gas is helium. So for getting helium configuration, it needs another one more electron. So that means this configuration is called duplet. Octet I have discussed in the previous slide. This is called what? Duplet. Only for hydrogen, lithium, which are nearer to helium. So those atoms which tries to gain the helium configuration, so those atoms only we call them as duplets. Okay. Now here hydrogen tries to achieve the helium configuration by accepting one electron. So whenever any element reacts with hydrogen, means it is either donating 1 electron. Okay, again see oxygen. What is the oxygen's atomic number? Oxygen's atomic number is 8. Oxygen's nearest noble gas is neon. So neon's atomic number is 10. So oxygen needs 2 electrons, right? Oxygen needs how many electrons? 2 electrons. That means in oxygen has atomic mass. How much is the atomic mass of single oxygen? 18 to 2, 16. In this 16, one part will associate with 1 electron. So another part is associated with another electron. That means here oxygen, whenever oxygen reacts with any compound, let it be carbon or hydrogen. For example, hydrogen. So oxygen is reacting with hydrogen. This is oxygen. It is reacting with 2 hydrogens. Okay, hydrogens. So here this oxygen, whenever, see for example, I will tell you the real life example. A person is having 2 daughters. He is having 1,000 crore of property with him. So he has married the 2 daughters with 2 guys. Okay, he has married his 2 daughters with 2 guys. Then how he will distribute his property to the 2 daughters after marriage? So 500 crore for one girl and 500 crore to another daughter. This is nothing but equivalent mass. So every electron is like a daughter for the atom. So whenever an electron it sends to in marriage with any other element atom, then what it will do? It will give some mass to that electron for that bond. So here see it is participating with one bond. So then what happens? So some amount of mass associates with this bond. Some amount of mass of this oxygen associates with. And both are daughters, right? So equally it will distribute. It will not give some daughter extra or to some daughter less. It will give exactly same amount of mass. So here oxygen's atomic mass is 16. So it is forming two bonds. It is sharing two electrons. For each electron it will share 8 grams and 8 grams. So like that. So equivalent weight means what? In a bond, whenever any atom forms a bond, it will associate some of its atomic mass to that bond. It will associate some of its atomic mass to its bond. So that mass which is associated for that bond is called equivalent mass or equivalent weight. Okay. So for oxygen, it can gain only 2 electrons, right? So that is the reason why it can only give 8 parts of oxygen for each electron. Similarly, chlorine, if you take, chlorine has got only 1 electron necessity because chlorine's next element is argon. So chlorine's atomic number is 17, argon's atomic number is 18. So chlorine can only accept 1 electron. So that means chlorine can associate its mass totally for 1 electron only, right? So likewise, chlorine's if you want equivalent weight means, so the weight that is necessary to react with 1 part of oxygen to 8 parts of oxygen, sorry, 1 part of hydrogen, 8 parts of oxygen, or 35.5 parts of chlorine. So this is considered as equivalent mass. Okay. So I hope you have understood this. So for example, always we cannot know if this is oxygen, hydrogen. These are easy. They are easy to remember. Oxygen's atomic number we know. So nearest noble gas we know. So we can see that 2 by 2 we can do. We can say 8 is the atomic equivalent mass. But whereas we are looking some kind of compounds which is having more than 1 atom or 2 atoms, then it is tough to find the this factor by which we need to divide for getting the equivalent mass. So for that only we call that as n factor. See here, for oxygen the n factor is 2 because it can only gain 2 electrons. So for oxygen the n factor which is deciding the equivalent mass is 2 for oxygen. For hydrogen it is 1. For chlorine it is 1 again because it can only take 1 electron, right? See, so for some atoms you can easily determine these n factors, but when you take multiple atoms like in a compound, so it is tough to find this n factor. So there are some rules. Okay, let us see those rules. For acids, the basicity means how many hydrogens it can leave when we mix it in water, dissolve it in water, number of ionizable hydrogens. So how many hydrogens it can release. Say H plus, HCl, when I drop it in water, so it dissociates as Cl minus and H plus, right? It can release 1 H. That means 1 is the n factor here. For bases, again ionizable OH minus. How many OH minus molecules it can release. So here 1 OH molecule is coming from NaOH, so that is acidity is 1. So likewise the n factor. For acids, what is the basicity? For bases, what is the acidity? And for salts, what is a charge of the positive ion or a negative ion? Both will be same. For example, Na3CO2. Okay, Na3CO2 or NaCO3, I think so. Na2CO3, yeah, Na2CO3. Na2CO3, it's not Na2 and CO3. If it dissociates, okay, if it dissociates, now it dissociates like this: 2 Na plus CO3 2 minus. So then positive charge is 2 plus and the negative charge is also 2 minus. So now like this we can find, so the charges, total positive charge or negative charge for salts. Na2CO3 is taken as an example, or CaCl2, you can take CaCl2 also you can take. So in CaCl2, here Ca 2 plus and 2 Cl minus. So here 2 is the total positive charge, 2 into minus 1, total negative charge also 2. So likewise the total positive or negative charge is taken as n factor for salts. For ions, what is charge on the ion? For example, any ion you can take Cl minus. So then the minus 1 is the n factor for ions. In redox reactions, the n factor. For a reducing agent, it is a number of electrons. See, you need to remember this, Leo. Loss of electrons is oxidation. Loss of electrons. So this, who loses electron is or reducing agent. So who loses electron is what? who loses electron is the it is oxidation. Okay, some person is losing electrons to the other element. Okay, that means it is a reducing agent. It is a reducing agent. It is what? Reducing agent. So for example, if I explain you with an example, for example, we can take MnO2 or CaO plus Cl2. Okay, now it forms a compound CaCl2 plus O2, for example. Now here calcium CaO, so it is losing oxygen. It is losing oxygen, right? It is losing oxygen, okay, and gaining chlorine. Here. So what calcium is doing here? Calcium is giving its electrons to chlorine. So that is, it is a reducing agent. It is oxidizing chlorine. So it is oxidizing chlorine. That means it is becoming, so gain of electrons. Gain of electrons means what? Leo is oxidation. Loss of electrons is oxidation. So gain of electrons is what? Reducing. So now the chlorine is gaining electrons, means it is getting reduced. It is getting reduced. The chlorine is getting reduced. Here we need to understand here, whenever any reducing agent always loses electron. Reducing agent always what? It loses electrons. Okay. See here FeSO4. Okay, here FeSO4 is a reducing agent. For example, here Fe, I think there is some error in this. I need to correct. Reducing agent 4. So for 2 minus will come. Okay, let it be. I will correct this. Let us see now. See, in redox reactions, the N factor for reducing agent is how many electrons it has lost. For oxidizing agent means how many electrons it has gained. Remember this. I will bring the examples modified in the next session. But for a while you need to remember this. A reducing agent loses electron. Okay. So how many electrons it has lost is the N factor. Oxidizing agent gains electron. So now here, if you look at this reaction, I have taken one example, right? So here now CaO. So Ca, now it will break up like this. See, I will explain here. CaO plus Cl2, CaCl2. Okay, or it may form CaOCl2 also. We don't take this example. Okay, let it be. I will bring a good example in the next session for explain, because the time is becoming long for the session. I don't want to extend the session much more than 30 minutes. So now what I will do is I will conclude it here. I will resume the session. In the next class I am going to take a good example and I will explain how we consider the these numbers N factor for redox reactions. I hope you have enjoyed the session. If you enjoyed the session, please like the video and subscribe to the channel and share it with your friends. Thank you so much.